Hello everyone. I don't expect that to not touch number at very early session. So thank you very much for coming. But normally this is the normal number, right? Or you have more than that? So anyway, we are recording the lecture just for people who are missing. So actually the lecture is a bit long. It's made for 4-hour lecture. Okay. So we will try to go a bit fast, a bit slow at the beginning, just to get the concept, and then later, okay. Okay, and later we will go a bit faster in the different planetary boundaries. So my first question, who of you already heard about this term planetary boundary? Okay, 4, 5. Okay, good. In which context you hear about this? Like, is just in media? Did you read about it, or
Really good papers connected to planetary boundaries.
okay? So you read papers, okay? Okay, sustainability goals. Okay, yeah, yeah. Okay, so the lecture actually today is structured in three sections. The first section will be like some evidence, just to convince some of you who is not convinced yet that we are in crisis, but just to convince these people that we are in crisis and we need to change things. And after that, we will go to introduce what's the 9 planetary boundary, and we will go in detail boundary by boundary. Maybe the last 2 or 3 boundaries we just go through it, but you have the presentation with you. And then by the end, we will introduce planetary boundary workshop, which I assume it's sometime this week, maybe Thursday or Wednesday. Okay. Good. Before we start, I don't want you to be depressed from the lecture. Normally, when I am teaching, all the lecture is, or the student will be happy after the teaching, except this lecture. But this is actually the message from this lecture, that we are in crisis and we need to move ahead and we need to find solution for this crisis. So when you are feeling depressed, this is not bad things, this is good things that you get the message. So you can see here, this is actually the delta oxygen 18, which is something we can measure. And this can be translated to temperature or a change in temperature over some hundreds of years or some thousands of years, actually. And you can see it's normally over the time you have low temperature, you have high temperature, low temperature, high temperature, and so on. But the strange thing is that you can see over the last 50 years or 100 years, we are over the limit and we almost stable. So in all the geological history, we are going from up to down, and there is some change, which is acceptable, no problem. But the strange thing that just the last 100 years, we are above the limit and we stable. If we look in detail, just in this 100-year, you will see there is a trend of temperature increasing. Okay. This is, for example, comparison between the temperature in 2013, so it's 10 years ago, and the average of 1950, 1980. And you can see almost everything is orange, except maybe Central Europe. Here we have like hot temperature than the average, but everything is orange, which means that increasing temperature, right? Okay, so if we see this one, this is 2024, so this year, this summer, and with a comparison with again 1850 and 80. What do you think? Yep, I think everything is now not orange anymore, but it's red, right? It's very hot. And it's not just numbers, all of us feeling it. We are in the Arctic, we are almost in middle of September, and we still feel it's hot, right? So they just to compare between the two figures, and the difference between this and that, just 10 years. It's not too much, it's 10 years. Well, if we look at something different that is somehow linked, is the increase of the sea level. So actually, we expect to have very high sea level by 2100. So in 50 years from now, or 70 years from now. And there is a strong evidence that the sea start to increase, the sea level start to increase. This is another evidence of this strange situation that we are in, which is the amount of the CO2. And again, it's comparison with the time. So from 5,000 BC, and then there is some increase, of course, of the CO2, but just here is something like 60, 70, 80. So around 1080 or so, there is a huge increase in the carbon dioxide. And this is if you look at this, it's somehow linked with the increasing in the temperature. Well, this increase in the carbon dioxide has a link to the change of the pH, because exist carbon dioxide that existing in the atmosphere will dissolve it in the ocean water, and this will change the pH of the water. And as a result of this change, this is what's called ocean acidification. And this ocean acidification actually is affecting negatively on the animals and plants, fishes, and things that live in ocean. Because you change the pH, you change the environment that these animals are living in, or this plant are living in, and this cause either this animal will die, or it will be very weak. So it's easy to be attacked by others. And you can see such nice figure. This is just before the ocean acidification, this increase or change of the pH of the water, and this is what happened after that. If we look at something different, which is us. So, of course, all of the previous evidence is just something created by someone. Okay, most probably us. But look at this figure. this is actually the amount of the fish that we use. And this is 1950, so 70 years ago. And this is 2018, like 6 years ago. And you can, the huge increase of using just fish. And this is just one type of food that we use. Of course, here, there is this is the marine caption fish. This is the aquaculture. This is the marine aquaculture fish. Okay, so actually we succeeded to decrease a bit the things that we catch from the marine, but we still consume a lot of fish, right? And in order to feed this fish, we need to use other source of food. Normally, we need to give them soya or something like this. And this is, we get it from somewhere else. So we consume a lot of food, we consume a lot of product as a human species, and we produce a lot of pollution and CO2 and other bad things. Good. So this is a figure to show how much we will use in the Earth biosphere. So, for example, in 1800, we was around 1 billion people, and we used as this amount of the biosphere. And then with the time, we start to increase the population and increase our using of the biosphere. And this is our future. So our near future is that we will consume everything. And we are going towards this. This is just to give you this figure in detail. So this is just a big figure here in detail, just to see what's happening in the different type of animal or the biodiversity around us. This is 1870. And this is 2012. And you can see all the different types of species. Marine, terrestrial, freshwater, the global, everything is just decrease. Good? Not good. Yes.
That's just biodiversity, right? So it's the different species on the planet. It's not like amount of species or amount.
No, different species.
Right.
Different species. As we will see in later part of the. Well, I think this is not the last slide, but maybe the last couple of slides. So now you saw that this is what we created so far for our planet. And this is our population. We increased from 1960 to, we are somewhere here, 2040. We increase. We start from here, actually, it's something maybe 3 billion. And now we are almost 9 billion. So it's more than double in 60 years or something like this, less than 60. What will happen here? It's another question. This is a different scenario for future. This is a different scenario for tomorrow. We can keep our increase rate to be like this. We can succeed to bend the curve to reduce the population somehow, and then we will start to go like this or like that. Or the world will go to be very crazy, and then the population will be jump to billions, 30, 40 billion. In any case, if we didn't succeed to bend the curve like this, if we go like this scenario, that scenario, or this scenario, These people who will grow here, who will born here, they need food, they need energy, they need resources. From where they will get? They will consume more resources from the earth. They will produce more pollution. Yep. Any question so far? Any disagree? Any agree? Oh.
Actually, like, it's the richest percentage of the population that has the biggest impact. So actually, it's not that all of those babies are going to have such a big impact if we actually address the amount of resources that we consume. That's an important conversation to be had, because we don't need to, like, tech doesn't need to, like, as it probably will, but it doesn't.
I completely agree with you. And this is one of the topics that will be, you will present actually during the seminar. So simply, we agree, because if you look at the real consumption rate of the different country, it's not equally. So you will find countries that from Africa or Far East or so, which are very poor, they do not consume a lot, but they have a lot of population. So their population is very high, but consumption rate is low. If you go to other countries, which is wealthy country, their population is not so high, but they consume. So this is something to do with equality between the developed nation and the underdeveloped nation. But what we try to discuss and present here is that we try to look at the overall planet. So you can imagine yourself now on Moon, for example, and you look at our planet. Okay, but within this number, within this story, there is, of course, a lot of diversity. There is a lot of like inequality between the different nations. And this is one of the tasks that you will do during the coming seminar. So this is just to summarize, somehow or the future, like increased population, this means consume more resources and more pollution. So actually, there is a need to define a safe operation space for human society to develop based on evolving understanding of function of Earth. So it doesn't make sense that we will keep ourselves like this. We will keep grow like this. We start to use the resources like this. We need a measure. You can't go to Yekta and you start to go to a shop and just buy computers and PCs and mobile and so on. You need to measure, right? You have to check your bank account. Okay, I have 10,000 krona, I can buy. Or no, I have only 2,000 krona. This is enough for my rest of the month, so I will not buy. So you need to have like measure to say, stop here. You need to stop, use these resources. You need to stop, use these things, or to find a way to fix the problem. And this is the planetary boundary. Okay, so the main point of the planetary boundary is this is not a solution. It's a scale to indicate how much we use resources. Okay, keep this in your mind during all the lecture. It's just a scale to tell you you consumed at this amount from our resources. Solution is not the problem of the planetary boundary. This is other people who should find solution to this. But well, actually, I assume you already with this. This is the three pillar model for the sustainability. And normally you see this, I think you saw this in Vera lecture as three equal circle. So this is the three equal circle. So in order to go for sustainability future, to make sustainable development, we need to have like really equal things: social, environment, and economy. Everyone should take care of each one. But the reality is like this. This is the Donald model or Mickey Mouse. This is the Mickey Mouse actually model. So the economy has a lot, and then people and environment, no one care about them. So this is actually the reality, unfortunately. So this is the planetary boundary. This is a 9 planetary boundary. I assume the majority of you saw this figure before. Yep. So the planetary boundary approach aim to define a safe operation space for human society to develop based on our evolved understanding of function and resilience of the Earth. So it's to define this operation space. So the boundary itself is between the green and the yellow. So we will go now to see how we can calculate these boundaries. But the boundary between the planetary boundary, we have nine boundaries, and the boundary is just between the green and the yellow. Okay? If you look in detail, everything that red color or yellow color, we already above the boundary. We already passed the boundary. Okay? This is actually to tell you how much we are ugly people, our human species. This is in 2009. When they calculate, we only passed 3 boundaries. And of course, by this time, 2009, everyone was aware of the crisis. We have a lot of agreement signed. We have the United Nations conference that is held every year, high-level conference for environmental and to protect our environment and protect the Earth. Everything was known by this time. But we still keep use resources. And then 2015, 4 planetary boundary passed. 2020, 1, 2, 3, 4, still 4. Or 5 actually, 1, 2, 3, 4, 5. And then 2022, 1, 2, 3, 4, 5, 6. And now we are completely 6. So we are now 6 out of 8, 9 planetary boundary passed. So we already use a lot of resources, and we have to work very hard in order to find solutions. So this figure indicate, maybe with a great agreement with you, Alex, that there is a lot of inequality. This figure indicate even from 2029, when this planetary boundary was already published, people aware of the crisis, not scientists, not public people, but policy people who make the decision, everyone was aware at this time. But everyone was, or still actually, lazy enough to keep the policy as it is. And now we are here. Okay? So this is the important message, or this is the important thing that you need to keep in your mind, that the planetary boundary is a framework, doesn't dictate how society should develop. It doesn't say you should use less resources, or you should keep the biodiversity or protect the biodiversity. It didn't tell you that. But it just like a measure to tell you how much we use from the different resources. Okay, good. So the concept of planetary boundary, we have 9 global processes regulates the stability of the land, atmosphere, and Earth. So in this planetary boundary, we have 9 boundaries, and these 9 boundaries observe or look in detail to the land, to the atmosphere, and to the water and sea. A tipping point in any of these planetary boundary may be reached when a change in a process doesn't give a linear response. A small change may have a large and unpredictable effect on the environment. So just to explain this, this means that, as I will show you in the coming slide, in this planetary boundary, we have like tipping point. If we pass this tipping point, what after that? It's something that unpredictable. We don't know exactly what will happen after that. Because the system will respond with something that we don't know. Okay? So estimate of the upper and lower value of the process have been made between which the response of the change is graduated. So actually here, it's just to say scientists are working to estimate this planetary boundaries. Okay, as we will see now in the different slides. So this is the tipping point story. So if you can link this with that, here, this is the green part. This line is the boundary. This is the tipping point, and this is between the green and the yellow. And after this tipping point is the yellow and the red. So, yep. Where is that?
The larger globe and the smaller globe in the tipping point figure.
This is a good question. Not really, but I assume that, you know, this is the earth and this is the earth. This is the good people and this is the bad people. So good people try to push the bad people in order to be like you see here, green people. And here the green people start to be a bit unhappy because they pass the tipping point, and here there is no green people at all because we already passed the tipping point. Okay. So it just gives you like impression that of how much we will be sad if we pass this tipping point. Okay. So actually, for the boundary, yes, for the boundary itself, they calculate the lower limit and the upper limit of when we should pass the boundary from different boundaries. Okay? And the planetary boundary is not the middle of this range, but it's the lower part of it. Where is now? Yes. It's actually the lower part. So when you are calculating a boundary, it's not the upper part because upper part you already passed the tipping point. It's not the tipping point because you need some time to make some measure in order to stop going into the worst scenario. It's the lower part. For example, this is the amount of the CO2 that we should not pass. Okay, that we produce. This is the upper amount. So if we produce this amount, we already very far away from the tipping point. We are somewhere here. And this is the lower part. So actually, once we touch this limit, we already there, almost there. So the average, this is the tipping point. But the boundary is the lower part. So our boundary for the CO2 is 300. This is just to give us a space to act. Okay. So to introduce you before we go to this, the planetary boundary you see here, we have one for climate change. And for climate change, we have two. We have the CO2 concentration and we have something called radioactive forcing. We have something for biodiversity. We have a planetary boundary for land use system or land use. We have one for fresh water, biochemical flow, ocean acidification, atmospheric ozone, and ozone depletion. And of course, novel identity. So this is the 9 planetary. We have out of these planetary boundaries, we have 2 that we can call them core planetary. This is the climate change one and the biodiversity. Why? Why they are core? Simply because they have the potential on its own to drive the Earth system into a new state. So these 2 planetary boundaries are very important. Even they both alone can drive the Earth into different situations. This is what is written in the literature. But for me, I believe as well, the fresh water is one, we can consider it as one of the core of the planet. And I will give you an example why I myself believe that fresh water is important, very important one, when we come to explain the fresh water. Okay, any questions so far? No questions? All agree? Yeah.
Change. Are all of these with tipping points or a steep decrease somewhere that's some value for the variable? And how would you otherwise, where would you otherwise place the boundary?
Where you place the boundary?
Like a steep.
Yes.
In the graph at one point?
Yes.
But is this the case for all the boundaries?
Yes.
Okay.
Yes. Almost, because we know that the boundary, I think it's written somewhere here. Should be written, yes, it should be written here. A linear response, a small change may have a large unpredictable effect. This is the steep slope. Because once you pass the tipping point and you are in this slope, you don't know what will happen. Okay. So this is the state 2023. We already succeeded as a human species to push the Earth to pass the climate change boundary. The biodiversity boundary, we already passed it. Land system change, we already passed it, across the boundary. Biogeochemical flow, we crossed it. Freshwater use, this year we succeed to cross it again. Novel identity as well. We still didn't cross the ocean acidification, so we can do something there. And erosion, we didn't succeed. The good thing is actually the good thing before last week. The good thing before last week that we succeeded to avoid the stratospheric ozone, which is great. And this happened sometime in 1978, 1987 or so. But actually last week, some scientists announced that they discovered the ozone hole again in near Antarctica. So actually, what we succeeded to avoid over the last 20 years, now they discover, okay, there is a problem, and we still have some challenge related to this. Okay, they just made last week. When we go now to the climate change, this is a core planetary boundary, and it's already crossed. And the climate change boundary, this is just to give you like background of the boundary itself, that the Earth's atmosphere is largely controlled by the greenhouse gas in the atmosphere. This is one fact. Evidence shows that period of higher atmospheric carbon dioxide are correlated with higher average global temperature. Atmospheric temperature affect wind pattern, ocean current, rainfall, and other precipitation. Positive feedback occur. Warmer sea melt, the polar ice melt, increase of the sea level. So actually, this is to show you the complication of increasing the temperature. This is just to show you the complication of this climate change. Once you start to play with the climate change, everything will come together. So the climate change itself is not a problem, or not a problem. The CO2 itself is not a problem, but the consequence of this is a problem. So once you increase CO2, okay, you have a strong correlation. So actually it's affect the temperature, and there is a strong correlation, as we show in the at the beginning of the lecture, that there is a correlation between the CO2 and the temperature in general. But once you increase the temperature, what happened? The sea level will increase, the polar ice will melt, okay? The carbon dioxide itself that is going around us will precipitate in the North Pole and the South Pole as ash, and this will increase the temperature of the ice and it will melt. It has something to do with the currents, with the pattern of wind, with the precipitation and rainfall. This is something to do with what we see every year from floods in Pakistan, in different countries. It has something to do with the scarcity of water. There is a lot of countries that now have no fresh water. Even in Europe, there is major rivers like Danube, for example, has no water. Okay, so it's not just the climate change. It's linked to other challenges. It's linked to other things that affect it. Okay, actually, the boundary now is defined by two things: the amount of the carbon dioxide and something called radioactive force. The radioactive force actually is the change in the energy balance of the Earth in general. Good. So actually the boundary, as I said, it's defined here at 350 ppm of the carbon dioxide. So we need to produce per year less than 350. Okay? But in 2023, we produced 400. Okay? We still somehow save, because if we look back, the number is 417. If we look back to this curve, the range of the boundary between 350, 550. So we're still here, we're still somewhere here. So we still can do something, but we're almost there. Okay? And the radioactive force, actually, as it was measured, it's in 2023 is 2.9. So the radioactive force is the total energy balance of the Earth. Okay, and we should not change this amount with more than 1 watt. So either positive or negative. Good. So actually we cross this boundary in 1988. And there is a lot of agreements. Actually, we will show this agreement now. A lot of agreement in order to keep the number low. So this is how we can mitigate, how to fix this problem. We need to go for international agreement. Actually, we will not need because we already have a lot of international agreement. So for example, in 1997, 84 countries, they came together and they agreed on something called Kyoto Protocol in order to reduce the greenhouse gases. In 2015, so 8 years from now, 10 years from now, during the COP21, 174 countries, they agreed to do something with the climate change, which is great, right? So you agree that it's great. Who is agree that it's great that we 174 countries signed this agreement? Please raise your hand if you're happy with this.
Could more, but
Yeah, with more, but you happy with this?
no, I want more. I want more.
You want more, okay. But at least 174 is okay. Right?
Agreement historically, and
Alex, yeah, yes. You get my mind, Alex. Okay, okay, okay. The major parts of this 172 are fighting now in Ukraine. Right? The major part of them, they decided now to use diesel and to use coal in order to produce energy. There is agreement, yes, we can sign agreement, but who will make this agreement in power? Right? The major country in the world, US, when Mr. Trump was there, he said, no, the economy is more important. I will not reduce the carbon dioxide. Right? And he signed this one. So agreement is not enough. We need people to understand we are in crisis. Not only understanding, but people to make action and push on their government. And the government should do something. Because agreement is there. Right? And I think I would like you to read this carefully. Most people accept that the biofuel industry has a role in the reduction of fossil fuel and that renewable resources should provide a greater portion of the energy we use. From you agree on that as one of the solution? Okay, Alex, okay.
Because renewable resources and everything. We have in Colombia our energy comes mostly from hydroelectric power, but when they build these things for that, they affect the environment as well. So it is a green energy. We don't have a lot of like other kind of or the sources for our energy, but it's not that we don't have a CO2 emission or damage. So again, it depends.
Yeah. Keep this opinion in after the break. Yeah. Who is agree with Alex? Who is agree with you? Other people?
I think technology is part of the problem. I think in the previous lecture, they mentioned that technology for using, for example, this renewable energy is good, but it's again, it's a part of another problem. So,
Yes.
yeah, so I agree.
Yes. Yes. Technology is part of the problem for two reasons. In order to produce renewable energy, okay, we need to stop now, but just finish this. So in order to produce renewable energy, you need battery, right? Powerful battery. from where you get the resources for the lithium and this element that used in the battery from the poor country. You go to poor country in Africa, in Far East or so, and get their resources in order to produce battery. Right? And there is children there, they are working to produce this material. They children like this, they just produce this material by their hand. And no one care. Okay? So this is one of the problem with the technology. Second one is how you are thinking about the technology. So a person at home, okay, there is AI and there is technology and there is renewable energy. I don't care anymore because there is solution. And everyone start to think, okay, technology will solve everything. But this is not the correct thing. So it has this two negative impact. One of them, you need a lot of resources, critical material, and you don't know how to get this. And the second one, how it give like set the mindset of the people that we can solve everything with technology, but no. To solve this problem, we need to change our habit of consumption. We need to reduce our consumption. But again, I need to use to keep this. I need to keep this that people believe that biofuel, renewable energy can be the solution for climate change. Okay? I assume, yeah, this is just again the Paris Agreement that 174 countries, they agreed to reduce the temperature and they cut the emission of the greenhouse gases by 2050 and 2100 and so on. And that two things that we need to highlight here, it's not written here. One of them that we need to review. This is one of the things that need you to focus. Review the action by each country every 5 years. This means every country signing this agreement should give to the UN data in order to be reviewed. Right? And one of your tasks is to tell me which of this country tell lie and give false information to the UN. Because, you know, there's some political things, you need to achieve the target, regardless what you already achieved, you will report fake number. Okay? And yeah, this is the second point. Rich country should help the poor nation. This is something that everyone agreed on. Great, so we can have like 10-minute break.
Den höga förekomsten av en inpassning och sökerlistans och flera andra som tidigare. Har du sett den här regeringen? Det här stod ju i februari. Fick du se in så här? Det är den där med fjärde formen. Det var kanske så. Om den nyansatte det är Nej, jag lite så sammanfattning så står det ska säga okej, vad är det går grejer till det. Jag inte so yesterday.
It'll come like at 11. I'm gonna put 11. You know, it's fully. Yeah, because I mean, this now and it's both. I was like, some shop. So it's just filthy on. That's why I say there. Yeah, that's that. But the parents said, I think not, and I think, you know, people get it, but so, yeah, I think that woman, any of it. Sometimes, yeah, but. Yeah, yes, the I'm starting to. No, it's not. I love this. It's not Andrew. I want
That's
It's almost. I lived once ago, thinking now. Yeah, so I'm not waiting. As you're I organize. I can put that out.
like export the gym.
I think that.
I expect to be a back.
I feel like some guys that's like practical feeling because that's the usual. But I just the spaces. Yeah, I have an other. Everything is not spot. You do. Better having just because yeah.
So I was to read my own business. It's just like it's this. Still, it's very a lot to see.
I will actually go. Yes, I
Of course, everyone's need to be like in the seat. 3 months of your problem.
Yeah.
Right. You say you were like just staying there.
I just.
Thank you. Everything hard. Oh, yeah. Yes, that's good. Okay. What's that? For breakfast, I think so.
Ja, han sa det. Ja, ja, den här. Det var väl det. Ja, jag tänkte vi ska gå. So I need your room.
Very good. Okay, so you choose the bar. Right. I think you commute after that, I said, Which one? Here's like that party. So if I see everybody has to go this thing. Here you go. Oh, it's a community. For the warning, because I'm also picking on it. It's all. Way too much. I just maybe I'm just because the
No, I don't know, for our.
hopefully I don't need to travel to you this semester. I got one research conference I need to go in October. Hopefully that will be get the point. But if I'm gonna take train, I think I'm gonna play for the hour. Yeah. It's That's a lot of it. That's all about. That's 4 hour, 5 plus. Oh, it's I'm working on my life cycle as a citizen for evaluate a life cycle of a product. It's impacting the environment so much. And your sessions you can focus on life by the first how we can sure. That's one of the sessions coming most. Here's your own session. AI. Yeah, to speed for each of the artists. Yeah, all the presentation. Yeah, some vacation days. Is there other? Three seconds on security. Yeah. After the conference, it's much to all the things that are in your stuff. I know that's that's your stuff. That's all. Are you changing? Yeah. I think that's. To travel so far. Going.
He's done.
Your time management.
Okay.
Yeah.
Okay, now we will go to the next boundary, which is a biodiversity, biosphere integrity boundary. This is one of the two boundaries. This boundary is already crossed. So now some background around this boundary. For example, here, like the first things like a fact that we destroy several ecosystems like tundra, coral reef, and tropical rainforest. If you look in detail for the population of different type of ecosystem, it's reduced in general, except human species, we are increased. If too few individuals in a species remain, so if we assume that we have one species, like population of a species at 1 million, and we succeeded to protect them, we succeeded to keep few of them. So if too few individuals in a species remain, the survival of the species may be under threat because we still have like very small number of population there. Species interact, so entire community come under threat. So actually, this is as you studying in biology. If a species disappear, all the ecosystem will suffer because this species actually is the food for another species. So if this species disappear, everyone in the ecosystem, all the species in the ecosystem start to under risk. So it's not a problem with one species, it's a problem with everything. So the boundary actually is defined by two things, function and genetic. So the genetic one actually is the number of species or the number of species that can be disappear per year. So the background, this means before the industry period, like 200, 300 years ago, it was like 1 million species. One species per million per year can disappear. They put the boundary to be 10 species, so it's acceptable to have 10 species disappear for each million species per year. But actually, the current number is more than 100 species. So we are very far above them. Very, very far. We are 10 times actually above them. Okay. The second part of the boundary is the function diversity, and this is the energy available to the ecosystem. And this is simply that we need resources enough to keep the ecosystem working. We need food enough to keep all the species working. So if you have a species in hand, but you don't have enough food for them, what's the point? You need to keep everyone to keep the ecosystem working. So you need to give them energy in order to keep things working. And if you look at the boundary, actually you see here the genetic one, we are very far away from the boundary. We are 10 times actually. So the boundary here is around 10 species, and now we are above 100, but also in the function as well, we are far away. So this is some ideas how we can predict, how we can solve this problem. We need to monitor biodiversity. We need to find a way for species to predict species, like for example, use seed bank or sperm bank. We need to find again international agreement in order to put in law that it's not allowed for people or not allowed for us to use or catch this type of species. Limit fishing when fishing are spawning. Limit the use of agriculture chemicals and fertilizer, and this will come in one of the boundaries. Increase public awareness. Okay. And actually, in order not to be very, very negative here, we here at Tromsø, the Sustainability Group, the Arctic Sustainability Lab, we are working a lot on this boundary, on the biodiversity. And we have several projects on this, and we succeeded to do something. in both increasing the awareness, both sort of push regulation in order to have regulation in action, and monitor biodiversity. And even we are working now to restore some species that disappeared from our ecosystem. So yeah, if you look at the figure of the biodiversity, we are in bad situation, but we can do something. And here in Tromsø, we succeeded to do something. And this actually give you, like, again, positive message. If some of you will work with biodiversity master thesis, you will contribute directly to solving this problem. So actually, you are not far away from solving the problem. You will contribute how to solve this problem very soon, in few months from now. But you need to be aware. Well, now we'll go to the land system change boundary. This is already crossed, as you see here. It's already crossed. And my question for you, who was reading this things about the climate change, that we can reduce the climate change somehow by using biofuel? Some of you already agreed on this, right? No one agree? So, okay. Yeah. So this is actually what is already existing in literature. So many people believe that biofuel can help us. Okay. Now I would like you to look at the land system change use, and you see how things is complicated. So the problem for the land use that natural ecosystem include rainforests, for example, have been used for urban development, rising living stock, farming include biofuel crops. So we cut forest. Forest is something to catch CO2. It's able to catch a lot of CO2. So we cut it just to produce food. We cut it in order to produce biofuel. So when you cut a forest, you start to grow new food, new type of food, new type of plants, and you need, of course, some chemical and fertilizer. And this fertilizer will degrade the remaining land. So actually, it will destroy the rest of the ecosystem. The production of biofuels groups growing for export means that not enough food may be produced for local use. So it's a problem that we cut forest, we change the use of the land in order to produce either food or biofuel. And now the people say, okay, biofuel is very important. We need to produce more because we need energy, renewable energy. And we cut something natural that catch CO2. And we start to produce a lot of biofuel. And we neglect the food that will be used to feed the people. Yeah. So this is something related to the boundary itself. First of all, no more than 50% of ice-free land should be used for crop growing and human habitation. No more than 50% of ice-free land. So we need first to remove all the ice-covered land, and the rest, only 15% we can use. Farming should be concentrated in the most productive area. We don't need to farm in any place. We need to see where is the most productive area and work. Of course, I have a comment here, but maybe I will tell it by the end. People should eat less meat to reduce the area under cultivation. More efficient crop plants should be grown. Okay. Before I go to the next slide, here I would like to come to this point. farming should be concentrated in the most productive area. Do you know where is the most productive area worldwide to produce food? Farming? Any thought? One of the best that you can really produce something there.
Western Europe.
Western Europe?
We
Maybe.
we just go now.
From where you get water? From rain, yeah, but rain is not sustainable. There is actually one country that can feed all the world. Yeah, Russia, of course. Sudan. Sudan is a huge country, has a flat landscape, and has a river Nile. And the soil of the Sudan is the best to farm food product. But why Sudan couldn't produce this type of food? Technology, but technology is not a big challenge, because if we go to the first thing of the climate change, the different agreement, developed country should help underdeveloped country. So if there is no enough technology in Sudan, we can, as Norway, for example, we can give them technology. Conflict. It's political conflict between nations. It's a third country. It's in Africa. So no one from the developed nation, big names, big countries, they don't want to support here, right? Because if we support Sudan to produce food, it will have a power. And we don't need to give her power. Regardless what the consequence, that we will not have food enough for ourselves, but it doesn't matter. We don't need to give them power. So again, this is the crisis, but the real situation is a bit different. And in the real situation, you have economy. This is the major factor, of course, that control everything. And you have political, and you have power, and you have conflicts.
I was just wondering, those bullet points, are they from the Richardson's or the Planetary Boundaries study?
No, this is just in general. Of course, there is some of them. Like, for example, this is the boundary itself. So this is from the literature.
Okay.
The rest is something just to open your mind. And this is nothing to do with everything around the boundary. And this is actually your workshop this week. The seminar is we will split ourselves into group, and each group will choose 1 or 2 boundary, and you will work in order to get more information about this boundary. And you will reflect on this boundary, like, if you agree, you disagree, what's the type of agreement that is made already to support this boundary, if the nation or the different country succeeded to follow this or not, things like this.
Yeah.
So actually, this is not everything. It's not everything. It's just like, something like to brainstorm, just to keep your
The workshop, that's all.
good master course.
Okay.
So I think this is a master course and this is a PhD, right? Anyone here PhD? You are mixed, okay. So you are in the wrong place, you're PhD. Okay, so anyone here is will attend the conference as well. Okay. Good, so we go now to the biochemical flow boundary, which is crossed. Now I tell you how things is complicated. We will return back to this one. For the land system change, why we change the land use? In order to produce food, right? So we cut forest, for example, in order to produce food to eat. And in order to be really productive food, concentrate on the most productive area in order to produce good, very good, large amount of food, we start to put fertilizer. We start to put phosphorus and nitrogen to the soil to make it produce a lot of food, right? Good. And this phosphorus and nitrogen find a way with the water to the sea. So the excess amount of this component go to the sea. And this is called what's called biochemical flow boundary, which is already crossed. So in order to fix a boundary, we destroy another. So the biochemical flow boundary is simple. We need to keep balance between the elements. So the balance of chemical element maintained by natural cycle has been decided. Fertilizer use, atmospheric nitrogen is fixed in the harbor process, and phosphorus is extracted from rocks. So we can just get nitrogen, we get phosphorus in order to maximize the impact of the land in order to produce more food. So we add this two component to the soil to feed ourselves, but we add more than the soil should use. And the excess should be in the next slide. And then we have also consumption of fossil fuel, biomass, and we have this nitrogen fixation, this increase this amount of this elements. And as a result, the amount of the extra amount for nitrate and phosphate run off into the bodies of water, like lakes or rivers or sea, and produce algal bloom, threat biodiversity, reduce the change in the pH of the water, and of course, we have this carbon dioxide problem, which we mentioned, related to the climate change. And as a result of this carbon dioxide problem, you change the CO2 or you change the pH of the water, and it causes the acidification. So this boundary is merely to tell you that we affect the chemical flow of the earth. So we add more material, we change this material, the concentration of this material, and as a result, everything starts to be in balance. So one of the boundary, actually the boundary now is measured by both phosphorus and nitrogen. One of this boundary is that no more than 62 million tons of nitrogen should be added to the ecosystem. This is when we speak about the nitrogen. Okay? How much? How much we should add? No more than 62. We currently, how much? And this is why we are somewhere here, almost 300. Okay? Of course, the boundary is defined by other elements, like phosphorus, and for each of these elements has their boundary. So for the nitrogen, we should not exceed 62 million ton. For the phosphorus, we have another number. Okay, so group, the student who will work on this boundary, you need to get the other number for the phosphorus. Well, this is something good and bad. Good because when we prepare this lecture like 3 weeks ago, we was we aware that we succeed to avoid this ozone layer, the problem with the ozone layer. But again, as I told you, just last week, scientists inform us that not anymore. So they found a hole in the ozone layer. Okay, who is aware of the ozone layer? Anyone of you know what the ozone layer is? All of you, great. So the problem is actually find it somewhere in 1970, around 1970. They discovered that the concentration of the ozone on the stratosphere decrease, and even they start to observe a hole in the ozone layer above Antarctica. Why ozone is important? Because actually ozone absorbs the ultraviolet light, and the ultraviolet light actually something is can cause like skin cancers and other things. And of course, it's energy. So maybe we didn't feel it, except of the cancer, but it gave more energy to the Earth. So the total energy of the Earth will shift toward more energy, which is negative. We have enough energy now. And this is the ultraviolet light generate change in the DNA, and this will damage organism and create this cancer in skin. In 1987, people came together and they signed the Montreal Protocol, and this is sort of international agreement in order to reduce the using of different substances like fluorine and chlorine. And this substance are the substance that destroys the ozone because it's interact with the ozone. And we succeeded actually to avoid this. So we succeeded to restore the ozone layer until last week. Okay, so actually this indicates that this is correct. Everything is right, but we can do something. How we did this? I remember when I was too young, and I am Egyptian, and Egypt is a poor country somehow. And you can see in the media, there is a lot of propaganda around the ozone layer. So they ask people not to use this chlorine and fluorine anymore. Try to stop using it. So actually this propaganda succeeded to increase awareness of the people worldwide, and we succeeded to stop it. So we can do it, but we need awareness. The problem is not with the agreement, the problem with the awareness. Boundaries. So the boundary actually is measured by something called Thompson unit. And the boundary should be, the thickness of the layer should be 276 Thompson. And in 2023, so last year, it was actually in 2016, it was 300 Thompson. Last year, it was 284. And it seemed to be that this year we are less than 276. But if we succeed to avoid it in a previous time, we will do it again. No problem. Well, we will go after that to ocean acidification boundary. This boundary, as you see here, we are still in green, which is good. And we can avoid this boundary. But how we can avoid this boundary? Because the boundary, actually, I don't need to explain it. It's easy peasy. Ocean acidification. We have a lot of CO2 in the earth, in the atmosphere. This CO2 starts to dissolve in the water. It changes the pH, and as a result, increase the ocean acidification, change the ecosystem. So in order to stop all of this cycle, we need to reduce the CO2. So in order to stop this one, we need to fix this one, the climate change. Again, here, this is a problem. We have carbon dioxide, and this carbon dioxide is go to the water, and this change the pH. The pH of the water before the industry period, it was like 8.16. Now it's 8.03, and this is not good. So we need to return it back to somehow 8.16. And the thing here, actually, in this boundary, the good thing to highlight here, it's a very, very long-term process, which means if we succeed today, if we imagine today we succeed to stop the CO2, this doesn't mean that we will not reach this point, because we still have a lot of CO2 on the sphere, and this CO2 will interact with the water. It's a complicated process. And even if we succeed to absorb all the CO2 that existing in the atmosphere, which is, of course, will be magic, in order to make the water release the CO2, again, it will take millions of years, because it's a complicated process. So in order to get it back to this number, it will take years. Of course, this is some effect of lower the pH, including that it will change the ecosystem, the planets, the plant and the different fish couldn't breathe, couldn't use the water. The photosynthesis process itself is affected. So it just to give you like what's the consequence of this. So the boundary actually is measured by the saturation between the aragonite and calcite. Calcite and aragonite is carbon dioxide mineral, so they are have carbon dioxide in their chemical formula. And this ratio between these two minerals, the calcite and aragonite, should be 1:1. Pre-industry actually is not 1:1. The pre-industry it was 3.4:1. Now we actually 2.8:1. The boundary is 2.72. So you see, this is the pre-industry. We are now here. We are almost will hit the boundary. So it's only 0.05 to hit the boundary. Okay. Well, actually, I think the fresh water, as I told you, we have two core boundaries, the climate change boundary and the biointegrity boundary. But personally, I believe that one of the major boundaries that really has a huge consequence is the fresh water. Why? Why do you think I believe that fresh water is important? Any thoughts? Yeah, but this is why this is a big reason.
The strongest decline by person was also threshold.
Okay, yeah, but still, I don't think this is one of the major things that make fresh water is, of course, you are trying to find why I think this is important. Sorry? Yeah. You start to get into the point somehow. Any thoughts linked to this point? Well, if we look at the two core boundary, climate change, who is carrying this now at the government, high level of government, about increase of the temperature in Southern Europe, in Spain or Italy? Now, this summer, I think Spain is like maybe 37 or so, which is too hot. Someone care? Not really. No, it's too hot. You can go to the sea. We try to fix it. Yeah, we know this is climate change. Who care about the biodiversity? Scientists, yes, scientists. We are scientists and we care. We are saying, okay, people, we are in crisis. We are losing biodiversity. But who care about the water? If you look, for example, back like 2 years ago, there is a huge conflict between Syria and Turkey because Turkey decided to build a dam between them. We have a war in East Africa that will be triggered very soon because Ethiopia built a dam on the River Nile. So this boundary causes wars between countries. Not this. This is a huge boundary. This is a cool boundary. This is actually will destroy our planet. Right. But no one from this high-level politician care about them. What's the meaning of climate change? Okay, no problem. I still need to produce a lot of CO2 to keep my economy. Biodiversity loss, we lose some species. Okay, I don't care. As a president of a country or so, I don't care. I care about my election. But here, everyone will care. So this is why I think this boundary can trigger a lot of conflict at the political level and war between countries. Okay, so we have in this boundary actually two sub-boundaries. We have something called blue water and the green water. The blue water actually is the water that we can drink, the water that we can see, like water in river, lakes, aquifers, and so on. Green water is the water that's stored in the soil, and this is the water that can be used by plant. The fundamental problem is that 2.5 of the water in the earth is fresh. Not all the water on the earth fresh. It's only 2.5. And out of this 2.5, 61 of them is frozen in ice. So actually the water that is available to be drink, if you remove, say 50%, 61, say 50%, it will be almost 1%. So we can drink only 1% of the available, right? Not all the 1%, not all the available fresh water, not all the 1% is drinkable. There is some of them contain toxic iron or dust. So even this 1%, not all of them we can drink. This problem, fresh water is not unified distributed around the world, and so some places have very little water. Some countries has enough water, some countries has no water. And this triggers conflict. Things that increase this problem, increased use of water for agricultural system, climate change, pollution, change in the land use. So if we start to cut forest in order to grow some food, we need to put water. So we need water. Increase human population and longer lifespan. So when we increase the number of the people, we need more water to make them drink. The consequence of this water, desertification, river may fail to reach the sea, and actually we have in Europe this case. So I think not last year, maybe year before, we have a big problem with the Danube, that there is not enough water there. Destroying in fishes, as you said, we have a lot of biodiversity linked to this fresh water. And of course, the loss of bodies of water gave a wider area more extreme temperature and make it more arid. So if you have a lake somewhere that makes the life of the people around this lake somehow acceptable, if this lake disappeared, the temperature will increase. That there is a big problem as a human species. We know there is a problem with the water. We still keep pumping water from the river, and we still keep pump water from the fossil water. So even we know there is problem, instead of think how we can fix this problem, we use more water. The boundary So actually the boundary is that we should not, all the human who are living on the planet, should not use more than 4,000 cubic kilometer per year. This year, we use 4,300 cubic kilometers. So actually, we already passed and crossed the boundary. Okay, we can of course save ourselves. We can like tip the curve. We can return back to the normal situation if we stop agriculture of food crops like biofuel, for example. Use drip system for food. Reuse and recycle the water. Use desalination water. So we can do something. But if we start to like increase the awareness, or the people say, okay, there is a problem here, we need to go for solution. But instead of going to solution, they pump more water from the aquifers, from the rivers, from their resources. And again, the point of the sustainability is to keep resources for the future. So for example, if we are here, a people, and we have a river here, and we see a problem with the river, we need to use more water. As a group here, we need to use more water. And we know that there is aquifer, underground aquifer of water. Normally, what countries now to do in order to get water for us, we just drill hole, get water from the underground, and we drink it. And no one care about future. What will happen if the water in the river disappear and the water in the underground aquifer disappear? Our children will not find any water to drink. Well, we go now to atmospheric aerosol boundary. We have 7 minutes. Now I think we have 2 more. Actually, the atmospheric aerosol boundary, this is the natural boundary that in the atmosphere. And this is like ash, for example. If you have a volcano and this volcano brings some ash to the atmosphere, this is the aerosol boundary. And this boundary actually it's affect both physical and chemical nature for the atmosphere, and for each of them has its chemical and physical properties. We don't know exactly how these ashes and this aerosol boundary affect us, but at least we know per year we have 800,000 cases. We have 800,000 persons die per year just because of this aerosol boundary. So, for example, this is just to give you an example of how this material affect us. So, the diesel engine actually produce small boundaries. This boundary or this material go to lung and cause cancer to the lung, and it's small enough in order to go to our blood vessels. And of course, this has a very high risk. There is some consequence, and this is just to give you like international consequence of this aerosol things. Like for example, I don't know when exactly, but some year ago, we have something called Asian brown cloud. And this Asian brown cloud cover around 10% of the sunlight on Asia or East Southern Asia. And this lowers the temperature, the change in the evaporation rate, and disrupt all the systems here. In the 1970 and 1980, we had a lot of problem in North Africa, in Sahara area and Sahel area. And this is simply, it's North Africa. It's actually caused because of pollution come from Europe. So again, it's not a matter of a country. It's not a matter of where you produce this ash. It's matter like international matter. You produce the ash here, but it will move there and start to create problems there. Okay. The boundary actually is measured by something called aerosol optical dB. And yes, you see here the boundary should not be more than 0.1, and we already 0.07, so we are almost there. But again, we still in the green part, so we can have something to do.
Because in the figure or for the planetary boundaries, this is a global average, if I remember correctly.
Mm.
But well, for many of the different boundaries, there are regions perhaps that are
Affected.
a bit harder, but they also have a higher problem with them, perhaps with other places. So even if the global average, it's not, as you mentioned, with the brown Asian cloud, regions will have a bigger issue.
Yes.
Is it helpful to focus on global averages when huge regions or even small regions are hit so hard nonetheless?
Well, actually, here in planetary boundary, you are look at the global average. Okay. But as you said, the problem can be different from country to another country. And this means when you are reporting back to the EU and say that I will work on this boundary, okay, because this is like an agreement between countries for this sustainability goal. We have this 17 sustainability goal, and different countries start to work on sustainability goal, which is somehow fit to this one. And they say, I would like to work on this sustainability goal, which will feed this boundary. The country should choose a sustainability goal or the boundary that they are heavily affected by. So, for example, Chinese and ASEAN part, they should work on this boundary. They should fix this problem.
Right, but wouldn't it then be more beneficial to have like a map or a heat map which shows the problematic?
Yes, it's existing.
Is such a figure misleading more than it's beneficial? Would it be better to have an overview of the global?
Well,
Those issues?
Again, don't mix between the concept. Why the planetary boundary? It's called planetary boundary. It's
Right.
for all the planet. Okay, but if you start to look in detail, and again, what I presented here, it's an overview for the 9 boundary. So in detail, if you look in detail, and this is, I hope that you will look in detail during the coming week or this week, and you start to present, okay, we have a problem here in the biodiversity flow, for example. But this problem, and this is the map of the world, actually is higher here and there and there. So the map is existing. This map is existing, and the countries, different countries, aware of this problem.
But does that figure then become misleading? Is it helpful?
No, again, when you start to read this figure, you look here at the full boundary, for full planet. If you would like to go in more detail, you need to look boundary by boundary over all the countries, or over all the continents. But is this really mislead? No, it's not mislead, because simply when we say that we are here, this means we are all the planet in catastrophe. If we say here, this doesn't mean that all the continents are happy. Maybe there is some continent that already passed the boundary, but we can still solve this problem because we still, as a planet, below the boundary. Okay? But there is some, of course, some location need more action. We need to do more action here or there. Yep.
If it's like tipping points, like with the end of the hill, like once the balls over the top, it start rolling. Like for some of these, those hills are on a local scale. Like nitrogen and phosphorus
Yes.
are local problems.
Yes.
So then if you would say like the boundary has not been crossed, you would think like this positive feedback loop is not yet taking place, but it could be taking place already.
Yes.
But whereas CO2, for example, does mix and it's a globally integrated
Yes.
system.
I completely agree. First of all, agree and disagree. In the disagree that when you are saying this is very local, it's not local, not very local. Because when you are produce chemical, for example, the things that you give, okay, the high effect will be in this country because this produce most of the chemicals, correct? But the water, the excess water will find a way to the other countries. Yes.
In Germany, but it is only dozens of kilometers across the border, so it's still like that's on a few hundred kilometer scale.
Then you know, you distribute it.
But not.
Yeah. But again, this is when we are look at the globe. And then if you are solving the problem, and this is it's good to highlight this point. Now, I think you are the best student in Tromsø, simply because you are studying the sustainability side. So actually you are studying a very huge problem. And you need to come with critical thinking, think outside of the box, innovation solution to help nation understand and solve this problem. This is why I think they are great mind in UIT. Okay, but if you think that you will solve all of these 9 planetary boundaries, it's impossible. There is no way to solve all of them as a person. You need to be aware of all of them. You need to be at the personal level to act like, you know, I will not use more resources more than I need because I know that I will affect in a negative way on these boundaries. But as a researcher, you are focused only on the biochemical flow, not everywhere, just on. Okay, or just in this country, or you focus on this novel or aerosol in China. I work only in this. Okay, so here just to give you the background, and then when you start to do your research, it's not supposed from you to solve everything. You focus on one of them. Yeah. Then we go to the novel identity. I think this is the last one. Good. I think we're almost there. Yeah, already past the time. Maybe we just will mention the novel identity. Novel identity is simply, it's something like the aerosol somehow. But the difference between them is that this is material that we made by ourselves. So the aerosol is something natural, something that comes, for example, with volcanoes, the air that is come with volcano. This is the novel identity, something that this novel identity, it's actually something that we produce by ourselves. If you buy a new mobile, for example, the shapes that is used in this mobile actually include these materials. And when you throw away your mobile, it's expired, it doesn't work anymore, throw it, this material will be crushed and it will be released on the atmosphere. And one of this material is the TDC, for example. This is an example. This is a material that was used 30 years, 40 years ago as a fertilizer to kill the small animals that growing on the plant. And they discover this is actually cause a lot of harm for human and for the ecosystem. And they succeed to stop it. So all the government say, no, we will not use this material. So the difference between the novel identity and the agent is that this one we produce by ourselves. It's chemicals that we make. Okay. Well, actually, this is the last slide. This is just a few things that we produce more than 100,000 of this material. Actually, this is the last slide. This is our situation today. Right? we have 6 out of 9 planetary boundary passed. We crossed. We have 2 scenarios. We can go and try to make great transition. And by this way, we try to return things back. So either we can succeed to make great transition, and this great transition in everywhere, in economy, in policy, awareness, increase the awareness of the people, do local studies, solve a small problem in order to reduce the planetary boundary, in order to make everything green again, or keep everything as it is, reduce CO2 as you like, go and make the economy flourish as you like, and then we will end with this. Right? So, sorry again, maybe you are depressed, but the message is that it's a crisis. I give you several examples that we can solve it. It's not something impossible. We can do it. And there is a lot of examples that we already did it. And the second thing, you as people who study sustainability science, you are the people who are responsible to increase awareness. You are the people who, when you today we are going to get lunch with your colleagues who are outside the class, you say, okay, do you know that we already passed 6 out of 9 planetary boundary? And you start to explain to them, to your family at home. In your consumption rate, try to inform yourself. I don't need to buy a mobile every year. Why I need to buy it every year? I can use my mobile if it's still functioning. No problem. Because this is resources. There is a lot of people who are working with this. There is kids with this age. They try to produce the material that is going for that. So you can at least make a change by make yourself aware, change your consumption habit. It will be great if you increase awareness of the people around you. And it will be super great if you start to involve solving this problem. And here, it's not expected from you to solve all the 9 planetary boundaries. No one can do that. But at least you can focus on one of them and just maybe choose one country that makes this big effect on this planetary boundary and try to inform the government there. People, you are doing wrong here. We need to fix that by that. Good? Great. So finally, I think I see you sometime, I don't know when exactly, but it should be Wednesday, okay? And it will be a seminar, and you're already in groups, right? You are PhD, you are not there. Yeah. I mean, for the master student who will attend the seminar, I think you are in group, research group, like small group. One group, okay, one group. So in this case, maybe you can choose 3 boundaries. Just 3 boundaries, out of them 3, 4 boundaries as you like, and then try to do as you, what's your name? Sorry, your name?
Andreas?
Andreas, yeah. How Andreas criticize the planetary boundary, that it's local frame. So try to get 3 planetary boundary, 2 of them, and start to study them in detail. Like bring maps. This is a map of the boundary. This country, China, for example, produce this amount of CO2, while this country is highly affected by the climate change, but they produce nothing or produce less. So try to choose 1 or 2 of these boundaries and try to give more figure in detail. So this lecture just gives you an overview, and the homework or the exercise of the seminar is to choose 2 boundaries and go a bit in more detail and start to see inside the boundary what's happening. Good. See what is being.
Thank you for the lecture.
Yeah, no problem.
I just had another question which I've saved for after.
Yeah, please.
Okay. Do you have like the Richardson map?
Which map?
Yes, any of them.
It's fine.
Yeah, precisely. It's like the safety boundaries, they are a perfect circle. They have the same radius no matter what.
Yes.
Why is it? Because I love this figure and I used it a lot, so that's why I also asked a few questions related to it. Just when it comes to like the use of nitrogen, you can see that the high critical risk or the
Yes.
purple zone, that's very close to the safe boundaries.
Yes.
But when it comes to the genetic of biosphere integrity, what is the proportion of the middle zone so much larger when the green zone is standardized? Why isn't everything proportional?
Okay. First, two things. First of them, I think they are using several scales.
Yes, of course.
So the scale here for the nitrogen is different than this one because this is measured by ppm.
Yes.
This is measured by ppm. The CO2.
Yes.
The radioactive force is using the watt for its energy. This genetic one is used by the number of species that is disappeared. So actually, it has different scale for each boundary.
Yes, which would make sense, except for I don't understand if that's the case.
Yeah.
How is the safe planet? How is the green zone standardized? How do they have the same?
Actually, they try to shift the boundary. If I have a piece of paper, I can explain to you. So say for example, we choose three boundaries: the nitrogen, for example, the biodiversity, and the CO2. Okay.
Do you have time for this, by the way?
Oh, no problem.
Okay, thank you.
I need just to check something.
Yes, of course.
To be sure I have time.
I only need to write today, so I have spare time, and it's so nice to get depth into this figure because
Yeah.
I find it very interesting.
Yes. So for the nitrogen thing, boundary is 6 million ton. For the biosphere, it should be less than 10 species. For the CO2, should be 350. And this is million ton. This is species number, and this is. Okay. And then you add this is a boundary, and this is our limit today. This is a boundary. This is our limit today. This is a boundary, and this is what we are producing today.
Right.
So what they are doing, they scale it down, like bring this down. Not the boundary, but everything.
Right. They're putting it into proportion.
Exactly.
That's
So
nice.
everything should be around here. This one should be here,
Right.
and the limit should be somewhere here.
Right.
This one should be here, and the limit should be somewhere here.
Right. But how, if you're able to standardize all of those, how doesn't that impact the rest? How does it, like the red zone and the purple zone, why shouldn't they, in that case, also become? Why is the
Yes.
purples?
Well,
a
actually, we can
standardized scale?
assume two things.
Okay.
First of all, we can assume that this zone should be here,
Okay.
and when they standardize it, they reduce this green one, and at the same time, this one reduced to be here. So actually, maybe we can say this red zone is really was far away. And then when we standardized it, it's become like this. And there is a second option, and I think I will go for the second option. It's most probably the researchers themselves, they make it a bit just to increase awareness.
Yes, because
Like,
that's what
you
I'm
know,
afraid.
Yeah, this is the
think you're
boundary.
right.
Yeah, this is a boundary, but why not? Maybe I can make it like this
Right.
and just increase the awareness by show, okay, we are really in the very red zone.
But that's not very scientific. That's, ooh.
But again, because it's published in Science,
Yeah, it's
it's
a good
in
journal.
Science or Nature or so,
It's a very good.
and sometimes this big journals is something to do with policy, and sometimes you need to show things with a very bold line, like okay, it should be here, but why not? You can increase it like this.
Right.
And again, all of these measures are very complicated measures. So,
Very.
for example,
So fascinating.
how you can count the number of species that disappear every year.
Right.
So there is a lot of error.
Of course there is.
So in this case, okay, the people when they throw the figure, okay, we are here, but there is error. Maybe the number of species is high, so increase it a bit.
But that's the the concept of like hard borders and like blurred borders.
borders,
That's
yes.
the
Yes.
error line, if I understood you
Sort of,
correctly.
yeah.
Yes,
Yes. But
But-
still, this can work for the hard.
fair enough. Okay,
Yeah.
but you believe the reason why it's they're not
Absolutely.
proportional out of course. That's okay.
I
That's
understand
understandable.
this,
Yes,
yes.
because I would look and I don't understand it
Yes.
because it feels very.
Very good.
I find it problematic when we're trying to raise so much. It creates what's it called? Burden shifting. We end up focusing so
Yes.
much on this one because
Exactly.
that one is scary.
Exactly. Exactly.
But this one is far more transgressive.
Yes. Yes.
But okay, then we are in the same understanding.
And I completely agree with you. Can mislead other people. Actually, I have a lecture. Maybe I can share it with you. It's a very short lecture, like 2 minutes,
Would appreciate
to
it.
present this problem. Like, everyone speak about climate change,
Right.
but the problem is not the climate change. It's biodiversity, it's land use, it's water resources.
Right, definitely.
So when we try to solve a problem, we don't need, actually this is called CO2 tunnel vision. Everyone
Hey.
has a tunnel vision. Okay,
Right.
CO2, we need to reduce CO2, but we have another problem.
Right. Yeah, no, I totally understand. In my field, we call it burden shifting, but I really like CO2 tunnel visioning. It's amazing. Thank you so much.
Yeah, you're welcome.
I will admit, it's kind of annoying, the PhD part that we're missing out of all of the cool workshops.
Yeah,
It's
but
very-
what? I think the workshop should be open for everyone.
It's
So I
exciting.
am giving this big data course.